Hello, good morning. How do you know the number on the call today is so low for what it's what I'll prefer not to continue the class actually. Yeah, I have just 7 people in this call. I don't know if the rest still have intention to join later. Okay. I think since there's a recording, okay, people can always go back to play the recording then. Yeah, take it from that angle. You're working on something last week, right? Or was it last week? Sorry, on Tuesday. We started something on Tuesday. Hello, can you all hear me? If you can hear me, I would like to see your response on the chat because it will be bad that we have few people on the call and still yet even the few people could not take anything from the class. Okay, yes, you can hear me. Great, 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 great. I thought today being a public holiday, people would, of course, when I mean people, I don't mean the working class people among us. I mean, yeah. Mhm. So we would need to continue from where we started or where we stopped on Tuesday. And we opened the Studio 5000 software. We saw how we can create a new project from the fixed Studio 5000 interface, the first screen pop-up that you get when you open when you open Studio 5000. And as well, we also experimented on how to open previously created or an ongoing project, something you're working on. I remember I also mentioned that this file extension for your PLC program, for Rockwell automation, for Allen Bradley programs, starting from yes, I need to state that starting from RS Logix 5000 is .acd. That is your file extension. Anywhere you come across a .acd file, it is Studio 5000 or RS Logix 5000 program file. It is a RS Logix 5000 or Studio 5000 program file. Then I remember that I mentioned that Studio 5000 is kind of a combination of your RS Logix and your factory talk. Of course, factory talk, factory talk can be in several different form. There's factory talk site edition. There's factory talk machine edition. I think machine edition was what was used to program for panels. That's your panel mounted HMI. While site edition was used to program for EC based HMI, GC based HMI. Yes, if I am, yeah. Yes, I am correct actually. So, and then we created a file. We added the PLC, if I am correct, 1759L75. That was the PLC model that we added to our project. Yeah. And then what else did we do? We uh, we added some modules to our project, and we started because from the beginning you already added your PLC, your CPU here. Then we added the communication module. What else did we add? We added the digital input module. Yeah. Mhm. Added the digital input module, and that was all. And I stated I would continue from there. We would continue from there today. Yes. So I believe you can all still hear me. So we would continue from there. I believe the screen you all can see is a Studio 5000 interface screen, right? And when you look at it, you have a section below that shows your recently used projects or recently opened projects. Hmm. If you have not tried to do anything after our last class. By the way, those of us that were part of the last class, did you save your project after the last class? I think I missed that. I think I missed that in the last class because we were supposed to save the project before we exit to the fact that if you did not save it, bro, I think you might be starting afresh. Yes, Samuel said he saved this. Great, Samuel. Nice work. Anything you are doing, always remember your save button. At the same time, you also be careful of your save button because most of the time, many software, the moment you press save, you might never be able to go back to undo, right? And if you don't press save as well, if something happens, whatever you've done to, you have lost it. So it goes back to the point before you saved, right? So uh, since I have one person who is following me, and I believe maybe the others too, yeah. So I'll just open the file I created, the project I created on Tuesday, so we can continue the class. I don't know how long this class will be. And then why did my screen stop? This guy has started again. Yeah. I guess I will just need to share the screen instead of sharing the particular window. Else will keep our screen will continue disconnecting instead of sharing the particular application based on the way Studio 5000 works. So let me just share the screen. Yeah. Okay. So from the last class, we created a program file. I named my, if you did the same thing, I named my Nigeria Automation First 2_0. Okay, I did underscore like because our file name cannot start with a number. And we also saw it last week when I tried to name the folder with starting with a number. The software itself did not allow it. Yeah. So and then we proceeded by adding our files to the program, adding our IO, sorry. And I told you that just like you have your device configuration in Siemens, what we have here in Rockwell is IO configuration. And so we added our back plane, and automatically you have your PLC. Yes. So each CPU for Rockwell have their specific back plane that they work with. Yeah. Which is chassis I showed you. I had to Google to show you the chassis, what the chassis looks like. And each of them have like yeah, each of those chassis would even have their model number if I'm correct. So when you are placing your order, You order your CPU and you order your chassis. Yeah, you order your CPU and you order your chassis. I think you pay for them separately, safe. So we would continue. We didn't add the digital IO. Okay, so we are adding the digital IO this morning. We're adding the digital IO. So you right click like I said in the last class, you right click. I said one thing I used to do is instead of waddling through all this entire catalog, I just unmark everything and go directly to the exact category of uh module type that I want to add to my project. I don't believe the meeting is not recorded. I think it was. I saw it pop up. Okay, I saw it being live streamed. Uh, I hope the host is on the call with us so that he can start the recording. Or let me check if I can start that on my own end here. Do I have the privilege to record the class? To record. Do you know the difference between this record to CPU? Aha, okay. Correct, Samuel. Okay, so we'll continue. Uh, I would use 1756. Oh, so 6 not 9. 1756. That's 156 IB 16 for my DC input. For my DC input. I will use it for my DC input. Then, like I said, you select create. And when you click on create, you have this pop-up that asks you to enter a name. So I'll just say um let me just say 1756 digital DI 01. Say for the fact that maybe I want to add two digital modules. It said invalid name. Why is that then? Invalid name. Wow. Okay. Oh, I started with. Is that why? Yes. I started with numbers again. Started with numbers again. I started with numbers again. So we can see that with Rockwell to the 5,000, you can't start a naming convention with a letter, with a number. Sorry, you can't start a naming convention with a number. When you look at this module too, you realize that it also have its own revision version, which I explained in the last class. I explained the revision version. You have your major revision and your minor revision. Then the compatibility mode describes how you match your um, physical device with um, what you are adding, what you are adding to it, like physically, and what you are adding in your actual project, the software part of it, right? Sorry for the skips. Uh, so let me add just yet another one. Also, the same type, yeah. And I just say maybe digital impute 0202, and that's all. That's all. So, and it's going to be on slot 3, right? So I just add that. And now I need to add my output. I need to add an output. So we look for an output model. And I think I showed us the distinctions between the output module types in the last class. Your output majorly starts with O for output, right? If it's AC powered, you have A. If it is DC powered, you have B. The rain is coming. I hope it does not obstruct the network. So, say for example, let's use a DC. These days you have DCs also. Let's use DC. OB16 or 8. Okay, let's use this OB32. Okay, I've seen an OB8. I'm just selecting anything. No, no special reason. Just selecting anything. No special reason. Yes. I know somebody is going to ask why why the 18 models? The 18 models, sorry, why the 8 model? The 8 terminal model. Nothing, 8 points. I want to add 8 devices, that's all. Or maybe my components is not up to it, or it's not more than 8. Yeah, that's all. If I have more than 8, the terminals left can serve as spare if if I foresee that there will be an expansion on my plans in the future, right? And if I don't see any reason for an expansion, I don't need to get, say, 16 or 32 points module because obviously the price will be more expensive from a vendor that is at Rockwell. They will sell it more expensive than the one with 8 points. And it means it adds to my project cost for no reason. So there's no point. But at the same time, if you foresee a future expansion, it's better you buy something that will be enough and you have enough spare for future expansion. So it's about trading costs and trading what's the English word for this? Scalability, yeah. Yeah. Trading costs and scalability. So all of these things is what distinguishes the engineer from yeah, from yeah. Okay. So how many slots do I have left? So we don't overpopulate these guys with unnecessary. Or should I just change this and put okay. I have just one slot left. I'll remove this deal guy. I'll remove this guy. So to remove a module, just delete it. Hmm? I'll delete this guy. Hey, what did I delete? I'll delete one of these. I deleted the deal. Okay. I wanted to delete DI. So I have one DU, one DI. Let me delete this and replace it with a 13 DU. Let me delete and replace it with a 13 DU. So to add new module. I think you can see how I'm removing the modules actually. It's part of the learning. Let me use OB16. 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 I saw OB16 the last time. Okay. And of course, there are some modules that are a combination. There should be modules that are a combination of DID, DID, EID, OB16. So you would see some OB16 with special functions, once this syncing sourcing, isolated output and all of that. To really, really confirm what those things stand for, what differentiates them. I'm sure that most of it will have to be about whether it is syncing, whether it's a dry relay output and all of that. You can just simply get the manual for those devices and reach because each of those modes would have their manual from which you can get further information about what they do actually or how they actually function. So you are not just selecting modules for the sake of selecting modules, right? And so I want to add an analog module this time around. Yes, that's what I removed. So I have how many slots left? So I want to add an analog module. Say this is a 16 channel arts analog module. So it means that this particular module is arts compatible. It's arts compatible. You also have the isolated heart out input and all of that. This is a non-isolated voltage current analog input. So let me look for it. There's not much to do with all of this. Create voltage or current. So it means that you can either specify it to work with a a a voltage transmitter or a current transmitter. So this is analog AI01. AI01. So we've added a digital module, we've added a digital output, we've added an analog input. We now want to add we we want to add an analog output here. An analog output. Yeah, analog output. Like I said, I and O is for output. So it's channel. This guy without heart, this normal analog voltage current is your regular 4 to 20 milliamp or 0 to 5 volts module, right? So we had that, and we would just, if you don't add this name to it, Alembrali, it won't give you a chance to move to the next detail. So you just need to add a name. Yeah, I think so, yes. Just need to add a name. So I do that, and I have, okay, that's because I pressed this again. I have a project. Yes. I have a project where I have a CPU L75. I have an Ethernet module in my rack. I have one digital input with 16 terminals, one digital output with 32 terminals, one analog input with 8 channels. 8 channels. That's it. I have eight channels. And I have one analog output with 8 channels as well. Hmm. Okay. Good. That's by the way. Having done that, if you recollect, uh, for example, when you were working with Siemens, there was certain setup you needed to do on your hardware configuration, right? There was some configuration you needed to do on your hardware configuration so that your PLC can understand how it's going to operate with this module, how it's going to communicate or how it's going to connect with those modules, how it's going to interpret the data it is receiving from those modules. So there's nothing much to do with digital, like I showed in the last class, just that I didn't save it. There's nothing much here, nothing serious here. Mm, nothing much here. And I think also the output module, there's nothing to do here per se. Output states drawn, mm, just advanced. But when we come to analog inputs, I wrote A1 here. So yeah. So These are your channels. We have four channels here, not not eight. Why is that? Okay. So when you select on channel 01 here, you can see you have the option of the input style. So for example, you have a transmitter that transmits 0 to 5 volts. You have to select this guy and specify that the reading that will be coming from the field is voltage, right? The reading that is coming from the field is voltage. The sweet thing about Studio 5000 is that very much unlike Siemens, where you need to do your norm X, scale X for scaling, you can you can do your direct scaling from your hardware configuration on Studio 5000. Yes, there's a scaling function inside Studio 5000 itself, but you can scale from your hardware configuration for Studio 5000. So take for example, I have this. I saw an argument on the group earlier this morning about scaling on X. Why do they use 0 to 1 range? I actually don't understand that 0 to 1 range. I don't know where the person picked that up from. The resolution for scaling in Siemens is 0 to 28,007. Is it 28 or 26,768 or thereabouts for Siemens? For Mr. Bushi, which I can remember very well, is 0 to 4,000. That's the scaling. That's how you scale. And all of those things is defined by the analog to digital converter that is built into the CPU. It's not something that you just pick randomly out of the blues, right? So if you read about, for example, if I remember very clearly that PLC theory book I sent to you, if you read about digital to analog converters under that subject, you would know how the digital to analog converter, how it breaks down uh, analog values, give you the binary equivalent of those values. And I think maybe that is where the person asking that question missed the point, right? You are not changing. So you have from your field, you have a value of 4 coming. Your PLC does not understand 4. So what does your PLC do? It changes your 4 to binary numbers for the PLC to understand. It changes to binary number. And you all know you know your decimal to binary conversions from secondary school, from primary school even. Yes, 4 divided by 2, 2 remainder 1 slash 1 remainder 0 slash all of those things. So that's what is going on, right? The only thing with analog is that there's a way your analog to digital converter, is a quantization, then sample and all of that to give you the bits, like the dots, that's fractional resolution of your value. That's why you can do the conversion and have a fractional value, right? So that's basically what is going on. That is basically what is going on. There is a ADC that picks the analog signal coming at 4 to 20 milliamps based on the resolution of that ADC device itself, which would be in the way they built it, either in a 16-bit resolution, 15-bit resolution, and all of that, right? It then converts into the binary equivalent of what it is seeing and then tells it to the PLC. So what you are now doing when you receive it in that integer value is that the ADC have converted it to the integer value that the PLC understands, right? Then you are now using your norm X to scale it. You're using your norm X to return it back to what you understand as a normal human being. That is what is going on. So with this hardware here, the hardware scaling for what do you call it? Rockwell. It's it's takes away the burden of converting from 4 to 20 milliamp 4 to 20 milliamp, then taking it to 0 to 247, whatever that you do in, what do you call it, in Siemens, before you now take it to the actual engineering value that you have with Skilex in Siemens. So what this hardware does with, what do you call it, with Studio 5000, it takes that burden off you, right? You just do your scaling directly from the raw field signal value to your raw to the actual engineering unit that you want to see on your screen. So that's basically what is going on. There is an ADC that does the conversion. Just the same way that if it is an output, analog output, there's a DAC, a digital to analog converter, that will now convert from the digital that the PLC is giving it in binaries to analog that what is outside can work with. Yes, can work with. So basically, that is what is going on. So we need to correct the confusion that was going on in the morning. I said in the morning yesterday. So we barely see voltage transmitters. I didn't say it does not exist. So we barely see them. And there's a reason for it. There is a distance you can cover with voltage transmission, like using voltage to transmit signals. The moment you have a very long distance transmission of voltage, there is the possibility of voltage drop because you are sending the signals through wires. Those wires have a resistance. Because of that resistance, there is always going to be a voltage drop. And when there is a voltage drop, it means you are transmitting 5 volts to tell your PLC that this thing is at its maximum value. But because of resistance on the line and voltage has dropped, before your value gets to the PLC, your PLC is receiving 4.7 something. Your 4.7 does not give the actual value that your transmitter is seeing on the field. I keep making a point. And you know, the longer your distance, the longer the resistance you are having. Ohm's law. Yeah. So we would, just because we always use, what do you call it, almost all the time. So for this channel, you know you are installing a pressure transmitter on the field, right? You already know you are installing a pressure transmitter on the field, and based on your IO listing and everything you've prepared before your project started, I believe Hope would have mentioned IO lists in his documentation lecture 2 Saturdays ago. So you've created an IO list. You've created what's the name of this document? So you already know the location where each of your device would be. You already know which terminal you intend, or which channel, which mode you intend to terminate them onto in your panel, right? So when you started your program, you already know that this channel 01, I have a pressure transmitter J. And this pressure transmitter that I intend to install has a reading range of 0 to 6 bar, right? So I will just come here and tell my PLC that my reading range is 0 to 6, so that your PLC knows that the 0 to 20 milliamps value that is coming from the field that I'm going to get here. Me, I want to scale it from 0 to 6. That is what I want to do. How to scale it from 0 to 6. But then we remember that 0 to 20 milliamp is not always the best. This is interesting. This particular module that we selected has capacity for, okay, it does not matter actually. Yeah, it does not matter. I understand why it's giving us just 0 milliamps to 20 milliamps option here. Yeah. So you are scaling 0 to 20 milliamps here. So it means when you have zero signal on the field, it means there is no, you have 0% here. Hmm. I'm try not to make a mistake here. Oh, okay. So you are the one that will specify here. Yeah. So by doing this, what you are telling your device is that when you have 4 milliamps, it means you have zero reading. You have zero value on the field. When you have 4 milliamps, you have zero value on the field. Once you have 20 milliamps, you have the maximum range of measure. Yes, you can change it. You have freedom. It's a democracy. Yes. Oh, today's democracy day. By the way, I hope you guys are enjoying your holiday. I know the response, actually. So you just click apply, right? And then your PLC knows that by, yeah, Nigerians, we like holiday too much, actually. We are one of the countries that have the most holidays in the world. We find opportunity to celebrate everything. It's not a bad thing. No, I'm not saying it's bad. Though. So take for instance, you want to make this temperature. Just put degree Celsius. There's this code I used to use to type degree. 0167. I can't remember that. Shift 0167. Let me try again. This shift or what? That's by the way, actually. So your low signal 4. And you do that across all boards, and you're good to go, right? Say, okay, you would need to do the same thing for your analog output too. And I barely can always compute some. Okay, come in. I think there's one other thing. Let me go back to the analog input. Analog input. Lab one. This is channel. Oh, it's not yet. It's not yet. There's something I know I'm trying to. Okay, let us select this channel. This mode is very, very different. Okay, so for this now, you can actually disable a channel. And for what you have here, you can disable the channel entirely. It means if you go and terminate something on this channel with this disable, you just wasted your time putting whatever it is there. It's not going to work. It's not going to work. So we want to. This has also been scaled. And so output state in program mode, hold the last state. Output state in fourth mode, hold the last state. I think what that is just trying to, what you're just trying to do with that is whenever you have an issue or when you are programming, you are working, the PLC is working before, then suddenly switch it to program mode. You want it to remember the last value it was having before you did that. Because I think we'll get to that actually. You can most Allen Bradley GLC. Even if we got to learn about the class this morning, we didn't add the CPU this morning. No. We added it on Tuesday. But then the CPU is a control logics 176. I hope you guys will be able to hear me. I will have to shout today. The rain has started here. So the CPU is 1756 L75 control logics. Is a control logic CPU. I believe you know how to hack the CPU. When communication fails in program mode, change outputs to fault mode starts, blah blah blah. Just click apply and okay. This is good. We don't need to. And if you can see here, I think you can just copy. You can just copy this by pressing this copy that you have below here. You can easily apply it to the same configuration to every other channel on that module. Channel 1, 2, 3, 4, 5, 6, 7. You can easily just apply it to it and just click apply. And then you are good to go. Now, I was actually looking for something earlier on, but then I can't find it underneath this. And then it occurred to me that perhaps it is something that has to do with. Okay. Aha. All of this differential data, single-ended data, high-speed data, they all have a meaning actually. Eh? They have a meaning. Meaning that I'll be honest with you, I cannot tell you definitely on this meeting or this call right now. But I can tell you that if you pick up the manual for this device, yes, I know it has to do with the way you are going to wire to the modules at the end of the day. And I think it is responsible for why for this place having I am having two channels instead of yes. Yeah, aha. It is responsible. So you see that when I came to this configuration here and I changed from differential data to single-ended data, the number of channels I have increased. So it has to do with the wiring and the terminations on the modules themselves. Because I remember when I opened this guy, I was surprised, like, why do I have four? I knew that I can change it. So then you can also change the data formats. Remember, if you do this, it affects all the channels you have on the module, all the channels on the module, all the channels you have on the module. Single-ended, you have 8 channels, and it has to do with the way you wire to those modules. If you pick up the 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 uh, the module manual for this device, you would see the different wiring approach to whichever data type you select. When I say data type, I am not talking about the data format, the types of flow. Okay, let me say input data type you select, whether it's single-ended, whether it's differential. You don't you don't wire them the same way. You don't wire them the same way. Your wiring will be different. The way you wire them will be different. And I believe when we go through the lesson too, we would see why those different approaches. And okay, yeah, that brings me to it. Sorry, I had a week.
and I dey talk, I dey wake up too. So, you could have a two-wire transmitter or a four-wire transmitter. Yes, yes, that is it actually. That is it here. So one of it goes with single wire, one goes with two wire. I believe the differential will go with four-wire transmitter. The single-ended data would go with a two-wire transmitter. We work with a two-wire transmitter. So when you talk about is that it? Would that be the reason actually? Sorry, I'm trying to think. Because your four-wire transmitter, you have the wire that takes power to the PLC and reads the data. Then you would have like an external exactor, that's external power that powers the transmitter itself to function. But I know it has to do with the type of transmitter you are terminating on your modules. So all of this information is also important, right? Know the transmitter, know which module you are adding it to. With that being said, right, we have concluded, we have finished adding what do we call it? Digital modules. Say digital input module or modules generally to our to our project. And so we can what we can simply do is just click on save to save our projects. Yes, I believe so. Yes, but to confirm, you can check the module to ascertain that I'm not saying the wrong thing. I could be wrong actually. Yeah. So this is how you can save your project. You can select on file, click on save, then save your project, or you just simply press this and save your project. Whichever you like, whichever suits you. You might like the long way, you might like the short way. They said one of those ways leads to heaven, the other leads to hell. So that's just a joke, actually. So, uh, having added this to our this thing, we can start our project, right? We can start our project. We can we can start our project. So first thing first, if you remember in your Siemens, you have your default tag table where you define your tags, start button. You say I'm addressing it to I 0.5, stop button, I'm addressing it to I 0. Whatever, right? There's also something that we do in PLC programming, which we call the input output mapping. Input output mapping, sometimes you might not really bother with Siemens because you can just go to your IO tag under the what do you call this guy? Properties of your module and just give a tag name, and the tag name just gets assigned to the address for that module. But with what do we call it? Rockwell, it is different. And I'll show you something. If we come to this controller tags are kind of global tags. Yes, I'll describe them as global tags. And when we say global tags, anybody that has been into programming generally for a long time, there's what we call your local tag, your global tag. Your global tags are tags that are available to every areas in your program, right? They are not limited to one specific place or one specific location, right? For example, when you were doing your CMS program, I know you guys worked on functions and function blocks, FC, FB. Even though I know many people will not understand the full concept of that FC and FB in your creating. The tags you created inside your FC is only available to the FC. it is not available for use outside that FC. So similarly, your controller tags here is like a global tags that is available, just like your PLC tags. The ones you put outside your tag and you label them as global inputs, global outputs. They are available in everywhere within your program for use. So also in Studio 5000, you have your controller tags. If you click on controller tags, you would see that you already have some things there populated on your behalf. Yes, I say so, on your behalf. So naturally, when you were adding all your modules, right, the PLC was creating a name, a tag for them inside its. Do I want to say the PLC is creating a name inside it? Because this program never entered the PLC. So your software was creating tag names, like it was creating tags for your projects. And when you look at it, you would see this local. Is this semicolon? No, not semicolon. Local colon 2 colon C. Then local 2 and I. This is the convention. The convention for IO addressing. Yes, IO addressing is Studio 5000. If you recollect in your Siemens class, IO addressing is I for digital, I 0 dot something. I indicating that it's an input. I indicating that it is an input. In the early era of PLC programming, right? If you put, was it with Siemens? Was it with Siemens or with brands like Alebra? From your IO addressing, you can tell the slots on which your PLC was positioned. You can tell the slots. You can tell the terminal it was terminated on. So initially, when programming started, when you put it on I, which is an input, then the slot number will be that 2 points. Then your terminal will be what will represent that one before everything became fluid, and you could assign personally an address to a single module. So even if your module is on slot 2, you can still go to your addressing table and say that no, me, I don't want to use I2 points. I want to use I12 points. But before, your slot number is always the first byte name. That is the I2 points. Okay, sorry for the break in transmission, right? Uh, it's raining heavily over here. I guess that's affected the network for a while, yeah, for a while. So, like I was saying, if we go back to programming with RS Logix 500, yes, the way RS Logix 500 labels or addresses its input or IO modules then it was different. It was I dot Z dot or semicolon B slash 2 slash 1 slash 3 like that. For Studio 5000, you have your local colon 2 colon C, and that is for configuration tags. If you click on this, you will see what all of these things mean. And if you even go back to your, what do you call it? If you go back to your hardware configuration, you will see the representation of this filter hub, whatever, inside your high configuration. But we don't need this, right? This is what we need because this is the guy that brings the input data into the PLC. This is for faults. So because of the modules have diagnostic functions, there's also a tag local 2I faults. Local 2I faults. That local 2 is indicating the slots that device is on your chassis. And this is for faults. Also, this one, we won't mind it. What is important to us is local 2I data. Local 2I data. Your I data 0. Does this even matter with what do you call this guy? With digital input? No. Where it is important is analog input. Let's go to local 4. But then we will need to know how do we monitor the outcome of these guys. So we'll get to that actually. So for your analog module is on slot 4 as well, right? Slot 4, you have local colon 4 colon C. Like I said, C adjust configuration data, showing if you apply the module filter, rate time sample, that's sample rates. This is for local 4C channel 0 config. So these are configuration data for channel 0. So if your alarm is disabled, there will be a number here. If your process alarm is latched, it will indicate here. Rate of alarm latch, range type, all of these things have meaning. Meanings that for you to know them, you would have to read the manual, right? But again, it's not so important except you want to do one or two things with them. What is important for us is the input that comes into the PLC through the module. And in this case, also, we don't need faults, right? We are not looking for the faults, at least not at this time. So we'll search for the data. So starting from here, and you would see already that your value is a float, your real value here. The values are float values here. So the local data that is coming into your PLC directly from field as scaled by your hardware module would display here under local 4 colon 4 colon I input dot channel 0 data. So whatever you terminate on channel 0, its scale value will be displayed here. The scale value will be displayed here. Whatever you terminate on channel 1, the scaled value will be displayed here because you have scaled from the hardware. Am I communicating? Because you have scaled from the hardware, it will be displayed here. Dear Daniel, check your configuration. How many devices do you have on your hardware, on your IO configuration? If you don't have anything on slot 5, you can't see local 5. So I'll close this back. Now, for local 5, you would see that you have local 5.c, local 5.I. Would I say you should disregard this I? I don't want to say that so that I don't mislead you. But I'm saying 8.8IA. I need to check the parameters of this module. That it is not a, of course, it can't be an output input. It's not an output input. So let us go back to our controller stand. So because of this module, we are terminating our output. We are terminating output devices on it, right? Where you would receive the values that you want to send out, or the way you would use to send values to your few devices. Say your pressure valve, your 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 VFD, if you are using analog to drive your VFD, right? This is where you will see the data that flows to the field from it. So you have local 5.0 indicating output, then channel 0. Then you click on this, then you see data. The actual value that goes to your final device, that is your output device, is you will find it here. You will find it here. This is where you will find it. Now, having said all of this, right? How do you add your tags to your program? Just the same way you did in Siemens. Naturally, when you are writing your program and you want to address it to an output module, right? Or an input module, it is this address that you have here that you are going to quote or call. This address that you have here is what you will address or call. But the dangers of this is that if something goes wrong with that terminal, for every instances or for everywhere you have used that address, you have to go and rename or change that address in your program. So imagine that you are using this data in 100 different locations in your program. It means you have to go to 100 different locations. Of course, in recent time, a lot of PLC have been having PLC programming software have been having this find replace capability, right? But then it's not something that is that cool, right? Let me put it that way. Not something like that cool. So what can I do? What can I do? If you want to add tags to your program on this module, let me close this guy. From this controller tag, if you click on it, you will see that you have underneath here, you have the monitor tab and the edit tags tab. Monitor tag, edit tab. The difference between these two is that when you are live on the PLC and you are monitoring what is going on in the PLC, this is where you monitor from. You can't edit anything from this tab. But if you want to make an edit, like say you want to add extra new tags or something to your program, you need to click on edit tags for you to be able to enter any tag. However, you need to know this. You cannot edit any of these self-created tags by the input modules you have added. You can't change this name. I was even trying to check if you can add alias. You can add alias. So I think alias is like your symbols that you have in your CMS. It's like symbol you have in your CMS. So what we will do is this now. Take for instance, you want to add a push button to your program. Start push button. Start PB. Top GB. Emergency. Top. I know it's not correct. Oh. I deliberately name it like that. So I know it's not correct. What else can we add? If you are trying to turn up a lamp, run, run motor. So at what instance do you use booleans for motors? That's if all what you are doing is a direct online start, right? So remember, you need to change this guy. These are bool variables. You can simply search for it actually. Just type bool. Then you add. If you want to make array, you want to make those things an array, you will just come here and increase this dimension number to 0. If you had an extra layer, it means you are doing a 2 by 2 or three dimension, a 2 dimension array, 3 dimension array. But in this instance, you're having just one array. That's if you want to create an array. That's what I'm showing you. But I'm not creating an array. I just need one single tag. So, and I want it to be a Boolean value. A bool value. Okay. Emergency stop. Also a bool value. I type 0. Bool value. This lamp to a bool value. Bool value. Bool. Now, before I change these guys to bool, when it was still double integer, you would observe something. If I click on this drop down here, I have moto.01, moto.0, moto.1, moto.2 up to 30, up to 31. So you can see easily even from here because I think Alebrali kind of show you very raw. Yes, what you're having here is double integers, but then your double integer double integer. If you remember when we were treating data type, integer requires 2 bytes, right? And 2 bytes is 16. Double integer then means it needs 32. So if you look at it, what this guy is indicating to us is that your D double integer is a combination of 32 Boolean memory spaces. That is what it just did. That is what it just did. If I change this guy to integer instead of double integer and I drop down, you can see the difference 0 to 15. Because naturally, on the raw surface, what have you guys taken your attendance? They have shared the attendance code in the chat since. So I hope it has not even expired. It's on the chat already. Maybe I should just retype it. SGR5N. Please take your attendance. I just dropped the attendance code. I just dropped the attendance code again. I just dropped the attendance code again. So I'm trying to wait so that people can take the attendance. Okay, I would continue. So I'm not using an integer here, I'm just using a bool. Under this description is like your comments. Description is like your comment in what do you call it? In in Siemens, yes, in Siemens. Okay. I think I can just we show the agenda. Top process emergency situation machine. I'm just putting anything, whatever comes to my mind. Yeah. Long running indicator. Motor run command. Motor run command. So this is how you add your tags. Remember, the tags you put in your controller tags are available in all sections of your program for use, like I said earlier, right?
Now, uh, Shoria Gbenga, how many times you want to share attendance code? SGR5M. Again, this is the last time. So, how lagba, who are these designers? So, for you to create an actual program, right, in Studio 5000, your programs are like taxes, right? Like a work order. It's your program that your PLC calls to perform an action, right? So in Siemens, unlike uh, in Studio 5000, unlike TIA Portal in Siemens, where you go to your program, the folder labeled program. In Studio 5000, you go to this folder labeled taxes. And then you would see something there where it is written main tax as a folder under taxes. And under main tax, you have main program. And under main program, you have main routine. Now, main routine in Studio 5000 is equivalent of your OP1 in Siemens. Is there anybody on this call that remember what OB1 is? That can tell me what OB1 is? Just raise up your hand or mute yourself and speak. Interesting. Does anybody on this call remember what OB1 is or how OB1 functions? Observation block. Interesting. Where else? Is it that you guys cannot mute yourself? Organization block. Yes, I know it is organization block. Michael Samuel is organization block. But what's the function of OB1? That is the first scan cycle. When your PLC starts reading, your PLC goes to OB1 to scan. And that is why when you are calling any other function, you call them from OB1. Now, OB1 is not only it's the main scan cycle, right? But it's not only this thing that your PLC goes to scan first all the time, right? There are also other OBs. There's OB35, OB81. Each of those OB have their functions and they have their instances when they come on. The difference is that OB1 is your cyclic. So every time your PLC is scanning, it is always scanning OB1. The OB5 is a periodic, yeah. The OB1 is a periodic OB35, sorry. OB35 is a periodic OB. OB1 is cyclic. So your program goes there, it scans top to bottom, and left to right, top to bottom. As soon as it finishes, it goes back, start again, left to right, top to bottom, left to right, top to bottom, left to right. It continues in that set like that over and over. OB1. Unlike OB35, where you specify the periodic intervals which you want the PLC to always go there and scan. And most of the time, OB5 35 is used for programming your PID control and all of that, right? And so I think we'll get to, I'll show you how to create a periodic tax in Studio 5000 as well, because you can also create a periodic tax. And in fact, this symbol behind your main tax here is what is indicating that this tax is a cyclic tax. So, okay, let me just, assuming I come on this tax,
Wetin my hand dey press like this. I come on this task here, this folder, and I right click. You will see asking me create a new task. If I say I want to create a new task, there's the option here. Do you want it to be periodic? Do you want it to be an event? Right? If you make it periodic, periodic, you have to specify the period at which you want the HMI to go and scan, stop, then after go back, scan, like a cycle, right? Scan for 10 minutes, or after 10 minutes, go and scan this program. When you are done executing, you leave. After another 10 minutes, go back, scan this program. When you are done, you leave. After go back, scan. When you are done, you leave. Right? That's what the periodic is. Say, she period scan. Okay. What do you observe in the symbol that you have for this period scan and this main task? Their symbols are different. The symbol here is different. The difference. So this one, this indicates that this is a cyclic task. This indicates that it's a cyclic task. I'll just delete this because it's not in the scope of. So event two will be something for like your hardware interrupts that you have in TIE portal. It's almost 12. It's almost 12. So, like I said, your controller tags here are available across your program. Now, parameters and local tags. Parameters and local tags are tags that will be available only within this tags because it falls under the folder of that tags. Only within this tags. I guess you guys understand. Coming, this is main program. Can I add a new program here? Yes. I can add a new program. Aha, this was where I was supposed to come. New program. Okay, you can also create a controller fault handler, power up handler. So this power up handler might be a program you want to come on immediately. Immediately your PLC comes on for the first time. Immediately your PLC comes on for the first time. I think Siemens also have an UB for that as well. I can't remember the UB number. So your main task, your main routine is your actual program area. The person will draw this line, there's no way you can clean it. So this is where your programming starts from, your main routine. Of course, you all know you can write all your program on OB1, everything that you want to control on OB1. If it is scalable for you, if it is good for you in terms of troubleshooting and all of that, you can put the entire thing on OB1. You can put the entire thing on OB1. The same way you can put your entire program on main routine as long as the program is not large and all of that. But the problem is by the time your project starts ballooning and it becomes so much. Imagine going through 1,000 runs of program in a single location, trying to troubleshoot. It will tire yourself. It's even worse when you are not the one who even wrote. Even the one you wrote yourself, say, you wrote 2, 3 years ago. The only thing that can save you is if you have a proper documentation where you stated why this wrong is functioning. If you don't have anything like that, even you will get lost in your own program, the program you wrote yourself. So main routine is where you have your actual program starting from. And if you look up here, you would see, how do I dock this guy? Yeah, I need to dock. So you would see your tools, just like you have in, what do you call this guy? In Siemens, you have your instruction tool set or instruction toolbox or whatever. And first, this thing is the favorite. Favorite just being that you are programming with ladder, of course. What's the main, the regular instructions you would always use? The regular instruction you would always use. Your examine on is the same thing as uh, normally open that we spoke about. Examine off is the same thing as normally closed. Then output energize, which is what we call coils in Siemens. Output unlatch is your reset in Siemens. Output latch is your set in Siemens. Like I said, same thing, different wordings, different times, but similar functions. So it's for you to know, I want to apply this thing. This is what I want to do. What is it referred to, or what is it called, or what is it known as in TIA portal? Sorry, in Studio 5000. And once you understand that, you are good to go. So, say for example, I just want a single button. What did I do to bring it to this screen? I just double tapped on the symbol that I have up here and say, I want to add a normally close, say, stop button. I double tap on this as well. And I want something to come on. And you would see when I added things that are inputs, the program arranged them to the left of the rung. When I added an output, the program arranged it to the right of the rung. That is where we're going to place it. You would also observe something, that this rung is red. This rung is red, and there's a reason why it is red. You can't have a program that is not tagged. Should also mention it. You would observe that when we were creating our controller tags, we were not assigning M0 points, whatever, whatever. With Studio 5000, Studio 5000 works with symbolic addressing. There is no absolute address like Siemens. There's no absolute address like Siemens. Studio 5000 works with symbolic addressing. States your symbol. Give your tag, whatever it is, a name. Tell the program the data type you want. By the time you download it into the PLC already allocated, the PLC would already allocate that this guy na boolean, na boolean variable. It needs just 1 bit whenever it is being called upon. Stop button needs just 1 bit whenever it is being called upon, and that's all, right? So you are not assigning to a data. Is there even data block here? There's no data block here. You're not assigning to a data block or anything. You're just pulling, just state your labels, give it a data type, and you're good to go. You're good to go. Now let me go back to my main program. Let me close all these tabs that I have here. Now I created some names, right, the other time. If I click on this question mark symbol and I select this drop down, it will bring all the list of variables in my controller tag and my main program tag, except I undo this. If I had labeled anything here before, it will not show it because of when because of I unticked this, right? If I untick this, everything that I labeled under controller tags here will not be visible to me again because of I unticked it. So I want to tag my start button to that guy. I will search for my start button. I want to tag my stop button to this guy. Catch my stop button. My rung is still red because the rung is incomplete. There's still an error. That's what this guy means. That there is an error on this rung. That is what this guy means. There's an error on this rung. So I want to run my process, right? I want to run my process. And I click, say run motor. As soon as I tag this to something, immediately the red disappeared. Means there's no error again in my program. No error again in my program. That is what it simply means. Now, I want to go back to my controller tag and tag something. Level 01 temperature. Then label this. Okay, I can use double integer, whatever I choose to use. It's my problem. So let me tag it to this. What do we observe? What do we observe? Why do I have red here now? Is there anybody on the call that can tell me why we have an error on this rung as soon as I hided level transmitter? How do I even see people who are raising their hand? I can't see that in this name. Is there anybody on the call that knows why we have an error on this rung after immediately I changed from the run motto to what do you call it? To level 1 transmitter. When you say because I'm not using the correct address, what do you mean? Uh, Co-host, please can you unmute anybody who raises his hand? We're trying to get the okay. Think from the participant list. Michael. You are raising up your hand. I can't unmute you. Interesting. Okay, Michael.
Okay. I
Yeah.
feel it's giving an error because the level one was supposed to be getting an input, not an output. So that's why the error message.
Why is it supposed to be getting an input and not an output?
Because of the double integer you used.
Okay. So one thing you said is correct. The other is not correct. It has nothing to do with input, output. Your program does not know which one is input or output. It's wherever you assign it to that makes it whether it's an input or an output, right? But then when I was declaring that tag here, I declared it a double integer, correct? But I assigned the tag to a bool because this coil is whatever you are assigning to a coil has to be a bool. because it's on and off. That is what it responds to. Yes, Juliet is correct. It is bool. That is why my level 1 temperature is just a digital, it's just a double integer, but what is required here is a bool, something that is declared as a bool. Do we get? So I will return it back to run, and the error goes away. So just the data type. It's a data type issue. A coil cannot accept a real value or a digital value. A coil is a bool. Just like your inputs, these two inputs here, the starts, what I assign to starts, what I assign to this are both bool. If I do the same thing, so by the way, you will see that I have just one rung here, labeled 0, and ended here. For me to initiate another rung in Studio 5000, I will click on this. Then it creates the next rung for me to work with. So take for example, I attach something like, say, my emergency stop to this, right? Then I want that when emergency stop is activated, I want to unlatch. I am assuming that this lamp was latched before. Now, this one corrects because the emergency stop is bool. This is a coil. Forget the function of that coil. So this coil unlatches something. This coil unlatches it. It's an instruction that says that the coil that has been latched should unlatch. This latch is different from the one you do by yourself. You can latch by saying, take for example, this rung, I want to add a branch. Now, there's a difference between, calm down, we are getting there. We are getting there. Studio 5000 has function block. It does not have function FC like Siemens. It has function block, but does not have FC like Siemens. Siemens, which one is Siemens? Siemens. Daniel, are you sure you've been following our class? Ah, if you latch this way and you are using this one to unlatch, you are deceiving yourself. If you latch this way and you are using this one to unlatch, what will happen is that because of the way the program scans, this will be the last activity that we go on. It means this motor will never run if this signal is enabled. This guy will never run because this will be where the cycle will be ending on. Where you use unlatch is if initially, I want to add another rung. Can we see the difference between rung and branches? If initially I have, say, uh, when emergency is not active, when emergency stop is not active, Hey, what am I doing? No? You see that when I added an extra this thing here, this guy went to red. That was an error actually. Large lamp. I know some of you will be like, this guy is not interesting, Yari. Why is the program looking like this? It's not fanciful like Siemens. Well, that's not the point. The point is your system working? Is your system working? Uh, the lamp. Okay. Uh, there are some conversation going on here. Coming. Let me quickly check on the chat box what you guys are saying. Level 1 is supposed to be declared. Strong data could use. Does it have something like HMI? Oh, okay. You are responding to Daniel. Of course, there is HMI in this thing. Now, maybe this is how I need to explain it to you, actually. So the way TIA Portal is built, right? You have a section where you can do add new device. So in a single project, in TIA Portal, I have not seen Toshiba PLC program before, so I don't know. I don't know how it looks like. Actually, but then when you see Mr. Bucci on GSWorks, GSWorks 2.0, yeah, GSWorks 2, I think you would think Logic Designer is beautiful actually. Maybe when you now see GSWorks 3, then okay, it would be like okay, they tried small, but even GSWorks 3 will stress you when programming Mr. Bucci. So the way TIA works is like the concept of TIA was totally integrated system whereby you can work on several devices in a single project folder. So if you create your projects, you had your you had your PLC, you had your HMI. There are two different folders, right? For you to work on your PLC, once you open your PLC and go to your program, TIA calls the component that works for PLC program and makes it available to you to program PLC. Within that same interface, you can go to your HMI project folder, open it, and TIA creates your project development interface for you. It opens your project development interface for you, dealing with HMIs. And I think there's also a drive section. So TIA incorporates the whole thing. But if you look at Studio 5000, when we opened Studio 5000 takes us to Logix Designer itself. And you create a Logix Designer project, just only a Logix Designer project. If you want to develop for your HMI, you will create a different project for your HMI separately. Unlike TIA Portal, where a single project can house as many devices as you have in your work. So, Daniel, I think that should address. So, yes, in Studio 5000, you can program an HMI. You can do your HMI design with Studio 5000. But you need to start a fresh project. And their extension is different. in your TIA portal, if you are using version 17, your project, both your HMI, your CPU, everything will be inside a single TIA file of, if it is version 17, .ap17, if it's 18, .ap18, .ap19, .ap20, everything will be in a single file that way. But with Studio 5000, if you are programming your PLC, Logix Designer will create a .acd file for your PLC separate. If you are programming an HMI, Logix Designer will create a .v, is it, I think VPD or VPR. I think VPR is your runtime file, while your VPD is the actual development file itself. Because the runtime file is different from the development file. The runtime file is what downloads into your PLC and runs on your, I said PLC, on your HMI, and runs on your HMI. Your development file is your raw development, your design itself. So once you do your design, you finish everything, you are downloading to the HMI. Your PLC will create, so your HMI will create, or your program will create a runtime file, download into your HMI. Is that runtime file that the HMI will read to function. So that settles that. So like I was explaining before, this run here, I have implemented a latch, right? Well, I used this output to latch this output back. This run, I used to latch. So when this guy is on, this is latched. What I did there is, if this guy is not active, latch this running lamp. Latch this running lamp. But the moment it becomes active, unlatch this same lamp. So it's the same thing as your set resets in Siemens that you did earlier. You have a separate trunk that sets that variable. You have a separate trunk that resets it. So that's what is going on here. Now, aside, we are far gone today. So I think when it's 12:30, we would stop and maybe take some questions. So outside of your Boolean and regular data types, right? You have other data types you can use. Say you want to create an alarm. These are other bits instructions as well. One shot rising, one shot falling. One shot rising is your rising edge or positive edge. I don't know. I don't. Did we touch on that in sim? We didn't touch on that in Siemens. So rising edge basically is just that once your signal is going from 0 to 1, it triggers once and goes back. And this happens only when the instruction, a particular instruction, is going from 0 to 1. Right? It's triggered once, one shot. It's kind of a way of capturing the instance or moment in which the device changed states from 0 to 1. Why one shot falling, on the other hand, or negative edge in some other programs, whichever language or whichever term they choose to use for it, right? Is it takes note of when a particular variable or device changes states from 1 to 0. We captures that instance. So I think it's something you can use to monitor that. Okay, you want to know at what point, or you want to know when this guy will change. Say, okay, you are counting, right? And your count is for you have a conveyor system. Cartons are going through them, and you have, say, a transmitter. No, it's not what I want to do. You have this guy, an input. You want to know when that input changes from, because it can, a carton is passing through it, right? And it can be in a closed state, in a on state for a long time. But you want to know when it goes off, and you want to know the number of times it went off, right? So you use your falling edge, your one shot your one shot falling to know that, okay, the carton passed in front of this sensor, and when it's left, like created a gap between it and the next carton, it goes from that high state to zero. And this one shot triggers once. So you can attach it to something like a counter. So when it triggers once, the counter counts one. Another carton passes. During that duration, when it is still passing through it, it remains one. The moment the profile of that carton passes through the sensor completely, it moves from that one state back to zero. And this one shot triggers and sends another this thing to your counter, and your counter counts two. That way you can use it as you can the I'm trying to explain an application of the one shot and the one shot rising, one shot falling, right? Like areas where you can use it. You can use it alongside counters to count, right? And stuff like that. So those are bits this thing. Then another this thing you have is you have your timers and counter, just like you have in Siemens. You have your time on counter, time on delay, your time off delay, retentive timer on delay, count up, count down, then reset to reset either your timer or your or your counters. Your timer or your counters. These ones are special. So you have your comparison tools. This is to compare. You are comparing one variable or the other. Equals to. No, not necessarily equals to actually. You would write your expression for comparison. Then you have limit tests. I've never used this. Max equal. You're equal to. You're not equal to. You're less, greater, less. We would work with them. I'm just showing you one after the other. Then your maths, your compute. What codes? Okay, I've not done the input output map. I will do that later. Add, multiply, subtract, divide, module operation, mode operation, uh, negative, absolute value, like that, right? So all of these are mathematics, maths, math instruction. Your move, these are move instruction. You want to move something from one address to the other. Maxed move, bitwise, and or X no, X or sorry, not swap bytes. You want to swap the order of the bytes. You want to clear something, bits distribute. I don't know maybe the person has a kid nearby, but then you should always, well, I don't know. So we have several functions, right? Several instructions that we can use for several different things in 25,000, just like we have them in Siemens. But we'll just work with the basic and common ones, right? That would not would not stress our head. So you have your jump to label, just like you have in TIA Portal, jump to subroutine and all of that. So now, speaking about IO mapping and so I want to map my outputs, right? And my inputs so that whenever I have a problem, I just go to my IO map, change my terminal tag there and have my values go to the tags and automatically it gets populated in all of my entire program. What I can do is I can do it on my main routine, but like I said, for a proper structured program, you don't just put everything on main routine or OB1 so that it becomes so that it's readable. I beg this person wey dey draw, make e help us clean am back too. It will be very nice. Thank you very much. So to add an extra routine to your program, what you do is you come to this main program, you right click on it, right? Then you say add new routine. So I can name it underscore 01 input mapping. Map input terminals to program tag. Okay. Then I'll come here, right? Now, I want to map this guy. I want to map this guy. Where can I find it? My controller tag, input and input data. You will see that all of these guys are bool, right? I'm still wondering why I have up to 16, 13 this thing here. So basically, your first terminal would go to local to I data 0. So to tag, so say for example, uh so I have to go back to where I have my input instructions, right? Now, this guy, the first terminal on my DI card is what I want to tag to my start push button. Say that is what I have designed in my IO configuration, my IO list. I would come here, local to I, because that is where you have your actual input, should I say input devices? Then I'll come under data, local to I data, right? Then it brings this drop down menus. It looks very tiny, but when you click on it, it brings the entire memory areas underneath that input stack that you have. Because of we are terminating on the first terminal of the module, right? We'll use the 0. Local to input data 0. Now, what we are doing is we are telling this guy that whenever something indicates, whenever what you have tagged to local 2 is active, push it into this address, start push button. That's basically what I've done. So the moment you wire a push button to this terminal, whenever you press that input, whenever you turn it on, you toggle it on and it is on, this guy automatically takes that value. So what you've done is you have mapped this variable, this local tag to this tag. So it then means that for this guy to become active here in your program, this guy needs to become active first. That's basically what you are doing with uh, input mapping. If I tag my next, and I will create another one. So I am also assuming again that my stop push button is terminated on the second terminal of my digital input module. Then I will come here. I know that my digital input module is on local 2. That's slot 2. Under data, it will ask me to select. So I pick 1. Data 1. Then I will go. I want to map it to the stop push button tag that I created. Then you will do this. You will continue doing it. Even if you have 1,000 tags. So these are the preliminary works you will do. Your IO, your input tag, your output tagging. You bring it in, you push it into this guy. So any activity that happens here reflects here. Then automatically it reflects in your program here. What it saves you is this. Once you go through that stress of doing this input-output mapping from the beginning of the project, it means if I have this button used in 2,000 places, 10,000 places, 4,000 places in my program, if this slot gets damaged for any reason while in operation, all I need to do is come here, change this address to wherever I retagged it to or I terminated to. So say for example, it was on data.0 before, the first terminal of your module, and for some reason that terminal gets damaged. All I simply need to do is the push button that goes to that terminal. I unscrew it from the terminal, then take it to the 7th terminal of the module. Automatically, I have corrected what would have been years of work trying to correct my program to now retag. So if this is what I did here, assuming this is what I did here, in my actual program, I used that 0 here for my stop push button. It means for every instance or for everywhere I use this guy in actual programs, I would always have to go there to correct it. So if this terminal had an issue, I will need to come back here and come and change the address to the new place I have terminated. So now imagine that I have to do this in 2,000 locations that I cannot even remember, or even 20,000 locations that I cannot even remember while programming. Am I making sense? That is the importance of input-output mapping. So I return this guy to what it used to be. Start. We don't even pass 12:30 again. Start. I have a problem here. I simply come here, change the bits, which means changing the terminal I was using. And then the correction takes effect across every location where I have used start push button in my program. It corrects it out automatically itself. This is for input mapping of digital. Input mapping for digitals. Input mapping for digitals. If I want to map for outputs, sorry, for analog, I would use my move instruction. I'll use my move instruction. So my source would be the analog input address. So we have analog input on local 4. And I said the actual data you are reading after the conversion and this thing by the hardware itself comes under data. So I will look for that channels data. Local 4 input channel. Now the good thing about Siemens Studio 5000 is that you can even create alarms within the module. And that is why you would see all of these addresses that you're having. You have low alarm, high alarm, low alarm. You can do all this configuration from your hardware module itself without needing to now start creating them in your program. You can do them from your hardware module. That's the beauty of this one. So now I have a transmitter, say my level 1 temperature that I created the other time, right? I have the transmitter there. I terminated it on channel 0 of my local 4 module. But then I don't want to always have to go back into my program to always change that guy. Then I will just move the data from local 4 input channel 0 data and send it directly to level transmitter. I will have an error here. Wow, it corrected it. I thought I was going to have an error because this guy is real value. Why this one is a double integer value, which are two different things actually. So what will happen with this is that the value that is coming from here will be approximated to the nearest, what do they call it? Whatever value it is, whether 100 or to the nearest approximate value actually, without a fraction. But so that we don't lose, because in reality and in truth, in some processes, 5 is different from 4.6. But if you approximate 4.6, it gives you 5. So you want your actual program scenario, right? Your actual scenario on the field. It is very important or very critical for you that an activity should not happen until you have an actual 5 bar on the field. Then what you went to go and do now is I went to do my input mapping of the actual 4.6 that is coming from the field, and I put it into a double integer value that would approximate it to 5. I have created a problem to the fidelity of my program by doing that, because it means that even when I don't have 5 bar, 5.0 bar on field, my program will be triggering to be giving me something else, or it will be carrying out an activity that I have programmed based on the instruction. I don't know if I'm clear here, right? So what I will do for this is I'll go back to my tags and just use a real value, right? So all of these things, all this thinking, all these thoughts needs to go into, like, it has to be behind your mind. It has to be at the back of your mind whenever you are writing your programs so that you don't create problems for yourself. Naturally, your program will not spot it as a problem because it agrees with it. But in real life scenario, in real programming scenario, in real functional safety scenario, on the field, it's an actual issue. It's an actual problem, right? So I need to correct that. So if I'm having 4.6 here, I should have 5.6 here, not 5. If I'm having 5.5 here, I should have 5.5 here, not 6. And yes, I think in mathematics, when we talk about rounding error, random error, and all of that thing. So you don't introduce all those kind of errors into your when you are writing your program. It's it's very, very important, right? I feel like I should stop here, or let me just do the output mapping, and we'll call it again. Let me just do the output mapping. So for the sake of structure, actually, I can do that on this same rung, on this same program file, this input mapping, this thing. I will just maybe rename it to input output mapping, right? I can do it here. But for the sake of structure, right, I will just right click, add a new routine. I can call it. The reason why I add numbers is for the sake of arrangements. So that, because Studio 5000 will rearrange all these things in descending, is it descending or ascending order based on the lettering and numbering that you have. So output, terminal, mapping to program tag, or program tag mapping to output terminal. It's like the other way around. It doesn't matter. Me, I just don't mind me. Program tag to, as long as you understand and the next person that picks it up understand what was done. Actually, is a lot of times people don't want anybody to know what they wrote here. So yeah, you can actually change the type of the programming language you want to use. And I think Studio 5000 is limited to ladder diagram, sequential function block, and structure test. If you remember my first class, structure test is the same thing as your SCL, structured control language in TIA. It is not the same thing as STL in TIA Portal or in Siemens. What they call STL in TIA Portal or Siemens is statement list. ST is structured test. It's different from STL. Don't make that mistake. I think I made a mistake in one interview I went for before. So you need to be very careful. Okay, so we don't waste time. I open this guy. Very quickly. I want to tag an output. Now, the difference between your input and your output is that you know from programming that you are already familiar with now for about 5 to 4 weeks now. That this is an input and this is an output. This is what goes to field. This is what comes into the PLC. This is what the PLC sees as an input. This is what the PLC sees as an output. So the reverse will be the case now. You want to run a motor, right? This motor that we are talking about is a direct online motor. So it means the motor starts immediately, maybe the relay coil comes on. So you have run. I guess we are seeing what is happening here. Code for what? Since when? Hey, God I beg. Now, I don't know if somebody still have the code you can share to send to output. We know that our digital output module is on slot 3, right? We'll come to slot 3, select local 3, 0, I say 0, no, O, which stands for output data. Then you click. If it is terminated on the first terminal of that module, you select 1. If it's terminated on second, you select, sorry, it is terminated on the first, you select 0. Terminated on the second, you select 1. Terminated on the third, you select 2. So let us assume it is on 2. We are assuming. We are not saying that is what it is. We are just assuming. Then say our lamp as well. And your lamp goes out to say the 8th terminal of the module. The 8th terminal on the module. Output data. If it's 7. So what you have done is this. If this guy gets damaged and you still have a spare module, you still have a spare terminal on your module, all you need to do is remove your wire, take it to the next available terminal, and just continue enjoying your life. No stress, no wahala. Safety, that's all. Because the actual guy that is working or running in your program, these guys, yeah. So your program is sending the output to this one. But because of you mapped it, you linked it, you have used that guy to send the output to the actual terminal you are terminated to on your module. Now, to round up for today, the same thing is for your analog. Like I said, for analog, you use move. For analog, you move the value. So let us assume on local 5 output channel uh channel 5, let's say channel 5, you come to channel 5 data. Wow. Hello, I'm still with you. I lost my extended screen because power just went off again. So okay, I should be back now. Can you okay shortly? Can you see my screen now? I would have to talk all of these guys. The code has expired because of you came in late. So can you see my screen? Okay. Local 5, channel 5 data. Then say you are using it for pressure to be too long. PCV 100. I am still having an error here because I have not declared this variable. And if you even look at it, you'll see that it's showing me undefined tag. I have not defined that tag. So my program does not give the PLC software, the 25,000 software does not know what it is. And so it is illegal for it to be there. So one way I can do that is I can go to my controller tags here and just add it directly from here. Or I can right click on this guy, right? And you would see new, new. If I select that new, it will give me this pop-up, right? Asking me different questions about what I'm trying to create. So uh, uh, I want to make it a real value. My data type is real. Okay. What's the scope? I want it to fall under my general Nigeria automation this thing. So it should be populated in this controller tag. That is why I selected Nigeria automation first. If I select main program, it will save it under these parameters and local tags that I have here. It will save it under these parameters and local tags that I have here. Let us try. If you come to controller tag, you will never see it there. But if I come here, parameters and local tag, you will find it because when I was defining that tag, I selected that it should be, I can edit the properties from here, edit properties, right? If I can't change, I thought I could change it from here. So it then means I have to delete it. For me to delete, I remember you can't delete anything, you can't make any modification on this monitor tags tab. So I need to move to edit tags. Then if I right click, then you see that the option for delete is available to me. Initially, when I was on the monitor tag, the option for delete was not available. Delete was not available. But when I come here, let me even try the properties, whether I'll be able to. Okay, I can't. I just need to delete it. Delete. Now, let me go back to my program again. And again, it is undefined again. Then go to new, make it real, a real variable. Then instead of main, Nigeria automation first. Then I click on create. If I come to my controller tags, you will find it under my controller tags because I declared it to be under this folder, the Nigeria automation first folder. So that way it is not a local variable. I can add description to make it easy to read. This is temperature, say at first level. Enter. Oh, sorry, enter does not work. Just click out and say inlet pressure control. Say percentage, just anything. What I added under description, I could have added from my pop-up the other time under description as well. It will show up here. So let me just see what I was doing already. If I come back here, you will see that the error we were having here is cancelled out. Now, finally, just like we have in NTIA portal, if you create a function and you don't call it in OB1, your PLC will not read whatever is going on in that function. The same way, if you create a program folder in Studio 5000 and you don't call it in your main routine, your program will not read it. It will not see it at all. Sorry, if you are not Yoruba. Your program will not read it. So what do? You go to your main routine and call that block. I would have called the block here, but I won't do that. The reason being that if I call it here, this program ahead that I have up here are relying on the things I have under for them to work. It does not make any logical sense. My input map, this start push button and stop push button, everything here are inside my input map. So my program will first read this one and then go and scan input mapping. How would it work? As how now, right? So what I will do is I will add an extra rung, right? Let me cut this rung. It won't work that way. Okay, let me add two extra rung, then paste it here, right? Aha. So for me to call those routine that I created, the input mapping routine and output mapping routine, I will come to my main routine, which I have opened here already. Let me close this guy so that we are not confusing each other with too much tabs on the screen. Now, I have created input mapping routine, output mapping routine. But I want my PLC to be able to read whatever is going on inside of it. I need to call them on my main routine. And how do I call them? In Semantic Manager, you use your jump subroutine instruction. Jump subroutine instruction, which I should be able to find under program control. So this JSR instruction is what I will use. Jump subroutine, JSR. Let me give you another quick tip. One way to know what something is doing. You click on the instruction and press. I thought why is F1 not working? Is it that I did not get to install my wow. Manual did not install with this guy when I was doing my installation. Oh shit. Okay. I wanted to show you how you can go to your help from this guy by pressing just F1. It takes you to your help and it gives you a description of what that symbol or what that is particular instruction does. So, what is the name of the routine we are trying to jump to? I want to jump to, you will see that the list of subroutines that we have, the list of routines that we have in our program is what it brought out for me. I want to jump to input mapping. Of course, the way your PLC works. First, scan input, go to your program, carry out the activity, then then update your output. So that sequence should also, I think that sequence too should also follow your program. This other this thing that you have here, input parameter, whatever, just oh my god, undo. Okay. Yeah, you can simply just copy this guy so that you don't waste time and say paste it here. And I can just change this to output mapping so that my program reads this instruction. It knows that it knows that whatever is going on this physical terminal should go to this place. Then after that, it goes into my program, read my instruction, perform whatever it has to do, update this guy. By updating this guy, then it goes into this output message, output mapping, then assign whatever happens on the run this thing to the physical output tag, and bam, we are good to go. And another way is you can separate your main program, process control. Right? For me to copy this, you press shift. Do you see what I did? Shift, press down, go down, then Control X. It cuts, I cut, then I come and paste it. Come and paste it here. Right? But what I've done is I've just tried to separate my program so that this main routine is not just loaded and burdened for no reason. Add range and okay. Me, I will just copy, delete this empty guy. Then change this one to my process routine. Then save. So this way, my PLC can read my input mapping, process my process control, then send an output map to the physical output, and the guy is running. It is good to go, right? So thank you all for joining the class today, for your patience. I think we started 10:30 and the day is fast spent. Do we have I have muted myself since morning. Interesting. Sorry. So I responded to Victor that the code is said to have expired. One. Uh, I responded to Emmanuel Adeboye that yes, it came late because the code has been shared a long time. Yes, just the same thing this guy was saying. It has been shared. So it's either you were not following us here actively. And you could be on the call, but I mentioned when the code was dropped now, and I reshared it twice. Some other people also reshared it. Do we have anybody that have questions that is not related with to attendance? Sorry about that. I think we would find a way around that for you guys. We'll find a way around that for you guys. So I have 21 people on this call. At the moment, I have 21 people on this call. And I've taken note of the 21 people I have right now. I hope you guys followed the instruction to use the names you registered with. If you didn't, then it's it's left to you. So those who are on the call who have not been able to take the attendance, we'll find a way around it for you guys. So since there is nobody with a question for me, I guess calm down now. Ha. Do you have a PLC at home that you will download to? For you to run the program, you have to download to the PLC. My guy is telling me that he has not taken attendance. Oga, you don't need the attendance now. Eh? My guy, you don't need the attendance now. You don't get the jump subroutine. Can you unmute yourself and explain what you did not get? See, Baba, you don't need it, I beg. We know those who need it. When I say you don't need it, I mean the attendance proper because yeah, it's we sum up to something at the end of the program, right? So Shodi Agbenga, can you omit and speak, please? Because when you say everything, I've spoken about a lot of things today. That's interesting. So in your PLC programming generally, right? When you are programming, all of these things are treated as folders, kind of folders, right? Which is why you would see everything you have here is one folder on its own, stored as controller tags. When it gets downloaded to the PLC, perhaps where the PLC will save it into will be different. This folder houses your taxes. This folder houses your taxes. Under taxes, you have main tax. Your main tax is a folder under taxes. And I also showed you how you can create another tax different from your main tax. Under your main tax, you have your main program. Under your main program, you have main routine. Before we now started adding subroutines, we started adding other routines to your main program. So your program, you can portion your program into routines. So think about it. On your factory floor, you have the section where your production is being run. You have the section, say a brewery, you have the section where you bottle. In fact, before you bottle, you have the section where you wash the bottles. When you are washing the bottle, there are sets of procedures. You call your caustic, you call hot water, you call cold water for rinsing, and all of that. Those things are routine activities that take place for your main program to happen, for your main bottle washing program or activity to happen. Now, when you've done that, you have this main routine, which is the actual function that we want to wash bottles. Main routine, we want to wash bottles. But under the washing of your bottle, we have sub activities that will take place. Call caustic, call hot water, raise temperature. Now, because you don't want to jam pack all of those things in a single main routine, you now break them down into routines, other routine, like, for example, your input mapping is a single routine of activities that maps your actual input terminals, your physical input terminals, which is indicated by these labels, into a variable that you want to use in your actual program function. You did the same thing for your output mapping, that when my PLC scans, execute, and all of that, I want it to send my output to these physical terminals. Then you put it in a separate. All of these things we have done in different routines. We could have just dumped everything here, like I showed you earlier on. We could just put everything here. So now, in this case, we have just 3 rungs, right? We have 3 rungs, right? Well, assuming I have dumped everything here, I have 3 rungs here, 3 rungs here, 3 rungs here. If I put all of those programs in main routine, I would already have 9 rungs in my main routine alone. Now, assume that I have a program that is large. I'm working on a very large project, and my run runs into several hundreds and thousands. It means that I would have to put my 1,000 runs in a single folder. In a single folder. But to avoid that, I have split all of those programs into different routines. Now, because my main routine is where the PLC scans when it is running, I need to call all of these guys here in the main routine, so that when the PLC comes alive and is reading, it reads this wrong and sees this instruction telling it to jump to subroutine. What is the subroutine it's asking it to jump to? It is asking it to jump into input mapping. So once my PLC scans this wrong, it goes into this place to perform the activities that are inside it. When it is done, it goes back to the main routine, scan the next rung. On the next rung, also, I am telling the PLC to jump to another subroutine called process control. Then the PLC goes to process control, opens it, reads the entire instruction that is inside of it. When it is done, it goes back to main routine. Then it scans again the following rung. Then the instruction says jump again to subroutine called output mapping, then it jumps back to output mapping, then it reads what is there. And this thing continues in cycles. In the scan cycle, it continues like it goes on and on and on and on and on like that. This scan cycle we are talking about, we don't see it because it happens in milliseconds. Michael Samuel, is that not the person who asked me the question? Do you understand? I hope I've not muted myself since. To be disastrous that I was speaking so passionately and nobody was hearing me. Ah, Shodi Agbenga. Okay, it was Shodi Agbenga I was explaining to. Okay, it is clear now. Fine. Good. Any other person with a question that does not have to do with attendance, please. Okay. Thank you all for your time today. I would end the meeting and we would it will have to be a class tomorrow again. All right. We'll see how it goes. Thank you all for your time and see you tomorrow. Victor, I said we would find a way around attendance. Don't ask me questions about attendance again. We've ended the topic of attendance for today, but we'll find a way around for today's class. For today's class, I've taken note of the people who are at the end of the who are still in class. Yes, so we'll find a way around that for you guys. Find a way around that for you guys. I will speak with the organizers. Okay. If there is no questions again, aside from attendance issue, I, I would call I'll call it a day. Thank you. God bless. See you in the next class. Leave. Where's the leave button? Come on. Now get coconut head. That's how I know the truth. I'm not in charge of attendance. Like, but the people in the class today are taking note of it. I will communicate with the organizers and see how we go about your attendance for you. And the reason why I'm doing that is because I also observed that when the attendance code was generated and sent to me via WhatsApp, I dropped it late. So it's possible that many of you, when by the time I put it on the chat, right, we already spent a lot of time already before you saw it and maybe it's expired. That is why I'm taking it. And so I have taken note of the people on the call. I will share with them. They will know how to sort it out. Your last 5 attendants, I don't know anything about them. I'm sorry for that. But for today's class, I will take it up and I will communicate with